assembly directives, right now, in previous lecture. Okay, that is first org and end directive we have taken, and then we will go for the next directive, that is db. So the function of a defined byte, as we have already studied in 8051 microcontroller, the same function is applicable for db directive used in PIC 16F877 microcontroller. So the function of db is to define the specific byte or specific characters as per our requirement, and in most of the cases db is used to define or assign some characters which are available in the form of ASCII values. Okay, so if we consider the ASCII values, so ASCII values consist of capital letters, small letters, special functions, that is symbols, @ hash, dollar, and symbol, star, whatever. Okay, and some numbers along with some mathematical expressions, symbols. Okay, so based on these characters, we are able to fetch these characters directly if we define as a db in single or double quotation marks, in single or double quotation marks. So most of the cases db directive is used to display the message or characters value on LCD display. So inside the program we will keep these characters in single quotation marks, in between single quotation marks or double quotation marks, so that we are able to fetch directly these characters or these message contents, and we will able to display on the display. So same function is used for 8051 and same function is applicable for PIC microcontroller. So db is used for that purpose only. And if we want to fetch some numbers purely, that is hexadecimal or decimal or binary, then also possible, but generally we are able to fetch the numbers directly from the various instructions. No need to use such special kind of instructions, simply we say that, or the directives. Okay, so db generally used to define a characters, and mostly in terms of ASCII values. So ASCII in the sense uppercase, lowercase, special symbols, and numbers, all are inclusive. Okay, so mostly these values are displayed on the LCD display with the help of this defining, that is db. So if you see in the example db 45H, so byte is defined with the value of 45H, and above that we have mentioned the 8-bit binary number, and last example is db, suppose bhel or whatever. Okay, so either you mention in single quotation or you mention in double quotation marks. Okay, so you just take a note that your third, write that. Okay, third directive is define byte. Okay, so write down this.
Completed, sir.
Okay, so with the help of this directive, mostly we prefer for the characters and the message, that is welcome, good morning, good day, like that. And before we define, we will go with some label like start, message, display, and these labels are associated with DPTR, so that the values of memory location are accessed up to the 16 bits. Okay. So next is EQU, that is equate, and next another one is set. So generally or basically these two directives are similar in function, except set directives value we are able to modify after some executions. The meaning is that if we consider the EQU, and both directives are also we have studied in the 8051. Am I right? Whether we have discussed these directives in 8051?
Yes, sir.
हॅलो, म्हणजे खरंच डिस्कस केलेत ना, नाहीतर मी म्हणाले म्हणून हो म्हणायचं असं काही नाही. होऊ शकतात चुकून. ओके, जर असतील तर तुम्हाला अंडरस्टँडिंगला आणखी सोपं होईल तिथं आणि इथं सुद्धा. सो when we talk about the EQU, that is equate directive, in that case, suppose in a particular program you are working on a specific application, and in that application some values need to be modified continuously, like you are developing the software for calculation of gold rates per gram or per 10 gram, whatever we consider per gram. So the rate of that particular gold is daily varying or continuously changing in time also. That is, before 1 hour rate is different, after 1 hour rate is different. So in that case, if we want to calculate the value for 1 gram, 10 gram, 100 gram, like that on your system, okay, and whosoever is the operator is there. In that case, if we cannot go with directives like EQU, in that case, or set, in that case, every time whenever you want to change the value, you need to enter in a program, and you have to modify all these values where you are used that particular number as a calculating parameter or factor. ओके, जर तुम्ही त्या प्रोग्राममध्ये त्याला 25 वेळा वापर केला असेल, तर जरी युजर डिफाईन केलं तुम्ही स्क्रीनला, तरी त्या युजरला किंवा त्या कस्टमरला 25 वेळा ती व्हॅल्यू एंटर करायला लागेल. आता काय सपोज रेट आहे की 5000 पर ग्रॅम, तर 5000 हे प्रत्येक वेळी एंटर करावे लागेल. पण जर तुम्ही असं काही फंक्शन डिफाईन केलं की जेणेकरून काय होईल, एकदाच चेंज केलं की ते सगळीकडे ऍप्लिकेबल असेल, त्यासाठी हे दोन डिरेक्टिव्ह आहेत, EQU आणि सेट डिरेक्टिव्ह. मोस्टली जिथं फ्लोटिंग व्हॅल्यूज आहेत, फ्लोटिंग इन द सेन्स ऑफ नॉट फ्लोटिंग पॉईंट 21.5 असं नाही, फ्लोटिंग म्हणजे व्हेरिएबल की टाइम टू टाइम विथ रिस्पेक्ट टू टाइम त्या चेंज होऊ शकतात, आयदर इन्क्रीमेंटिंग आयदर डिक्रीमेंटिंग. त्या केसमध्ये युजर डिफाईन करण्यासाठी किंवा युजर फ्रेंडली करण्यासाठी आपण काय करतोय की EQU और सेट डिरेक्टिव्ह यूज करतोय. ओके, आता EQU चा वापर काय, तर जेव्हा तुम्हाला एखादी व्हॅल्यू चेंज करायची, आणि एकदा चेंज केलं ती तर मल्टिपल टाइम्स चेंज होईलच, नो प्रॉब्लेम, पण नंतर आफ्टर 1 सेकंड 10 सेकंड 1 मिनिट ते मॉडिफाय करायची गरज नाही. त्या केसमध्ये आपण प्रेफर करतो EQU. दॅट इज फॉर एक्झाम्पल लेबल EQU 1000H किंवा काउंट EQU 25. इथं 25 काय, काउंट ह्या लेबलला असाइन केलाय. लेबल EQU 1000H लेबल या लेबलला, किंवा इथं दुसरा नंबर घेऊ शकतो आपण. तर लेबलला असाइन काय केलं, ॲड्रेस 1000H. परत तुम्हाला चेंज करायचं असेल तर तुम्ही चेंज करू शकता, किंवा नंबर घेतला स्पेसिफिक आपण ॲज अ प्युअर नंबर, काउंट EQU 25, आणि नंतर आपल्याला तो काउंट जो काही 25 व्हॅल्यू आहे तो मल्टिपल ॲप्लिकेशन्सला वापरायचा, मल्टिपल इन्स्ट्रक्शनला यूज करायचा. तर काय, मूव R2, #count, त्याच्यानंतर ॲड A, count, वॉट एव्हर द ॲप्लिकेशन्स आर देअर, परत मूव R5, count, असे काही मल्टिपल टाइम्स यूज करायचे असतील. आणि जर तुम्ही प्रत्येक वेळी इन्स्टेड ऑफ चेंजिंग दॅट पर्टिक्युलर नंबर 25 25 25 परत चेंज झाला तो झाला 30. मग 30 चेंज करण्याच्या ऐवजी फक्त काउंट जिथं म्हटलंय काउंट EQ 25 तिथंच फक्त एकदा चेंज करायचं 30. मग काय होईल ऑटोमॅटिकली पुढचे सगळे व्हॅल्यूज चेंज होतील. त्याला काय म्हणतो आपण EQU डिरेक्टिव्ह. कॉन्स्टंट नंबर इज असाइन फॉर ए पर्टिक्युलर लेबल इज नथिंग बट EQU इक्वेट. त्याच्या पुढचं व्हर्जन जे आहे ते सेट असेल. सेट मध्ये काय डिफरन्स आहे विच इज much similar to the EQU, but only difference is that whenever you want to make a modification after some execution of instructions. 10 ठिकाणी वापरले 5 ठिकाणी वापरले आणि त्याच्यानंतर तुम्हाला काहीतरी व्हॅल्यू वेगळी पाहिजे आणि तिथून पुढे वेगळी पाहिजे. त्या केसमध्ये तुम्ही काय करायचं सेट डिरेक्टिव्हला जायचं. सो इन दॅट सेट डिरेक्टिव्ह यू डिफाइन युअर required number and after that set directive it will continue with that particular value and before values are not going to be modified. अगोदरचे व्हॅल्यूज मॉडिफाय होणार नाहीत. नंतरचे जे काही व्हॅल्यूज तुम्ही ऍड कराल किंवा जिथं जिथं पाहिजे असेल तिथं तिथं काय होतील तुमचे मॉडिफिकेशन कॅरीड ओव्हर होतील. लक्षात येते ओनली वन डिफरन्स बिटवीन EQU अँड सेट. The basic function of both directive remains same. We will use or keep a particular number constant in the assigned label before EQU or before set, and as per requirement we have to modify only one time in that directive only. The rest of the values will be automatically assigned for the given label, whatever label is there. Here we discuss related to the count is a label and value assigned to count is 25. Are you getting?
Yes, sir.
Okay. So start writing. Mane Abhishek and Ajay, 41. Do not mention your roll numbers in chat box. We will take attendance afterwards. Abhishek, you need to modify your profile setting. Your first name should be started with your roll number and then your name. Please make it correction. Huh? Those who are remaining for modification in profile name of Google account, please make it correction.
Completed, sir.
Okay. So after this, we will go for next directive. That is, we have already discussed related to the end. After that, list directive. So the list directive is generally used for specifying a particular series of an controller. So in case of PIC microcontroller, we need to define which series we have preferred. As we have discussed, the PIC starts from 12F, 10F itself also. Okay, 10F, 12F, 14F, 16F, 17F, 18F, and it will reach up to the 34F. Okay, so various series is there. So out of that, which series we have preferred and a specific part number also 874, 875, 877, 878 like that. So here we discuss related to the 16F 877A series microcontroller. So if you want to define, be specific for that particular series or range of microcontroller, in that case you should go with this directive, that is list directive. Okay, and the specifying the list is like list, suppose P is the name of your controller you want to define, and the series actual technical name is 16F877 or 16F877A. So in this way we are able to define the particular series of a PIC microcontroller. Okay, so the basic use of this directive is to define or specify the which PIC microcontroller we are going to use in our program. Mm, okay, so this is related to the only specification or identification of a particular controller. This is the only use of this directive. So take it down, please. one more announcement for you, that is tomorrow lectures are scheduled as per the timetable of Monday. That is Monday's timetable will be observed tomorrow, and on Monday there will be a holiday for all of us. Okay. So you have to attend the lectures tomorrow, that is on Sunday, and the timetable applicable for tomorrow's lectures will be Monday's timetable. So as per Monday's schedule, all the lectures or practical whatever is there, it will be conducted. So, and on Monday you have holiday for the lectures. Okay, so take a note of it and attend all the lectures or sessions tomorrow. So tomorrow there will be no holiday for students.
Completed, sir.
Okay, so after this we will go for the next. These are again some directives which are used, and generally we not used all these directives, only as per our requirement we will use, and basically ORG and sometimes EQU directive we are using, but remaining directives are also applicable as per our need or requirement. So provision is there, and some unique provision is available in PIC 16 years, that is like list, which is not available in 8051. After that, see the here configuration word directive, that is CONFIG config, and then radix. Okay, so these are additional or unique directives available or used for defining PIC microcontroller. So we'll see the hash include. The include directive tells the PIC assembler to use libraries, whatever the libraries are available with that. So for defining these libraries, we will use hash include directive. Okay, so for defining libraries of various peripherals which are interface with the PIC microcontroller. PIC बरोबर जे इंटरफेस करणार आहे, सपोज अल्ट्रासोनिक आहे, LCD आहे, RTC आहे, एक्सटर्नल मेमरी आहे, okay, and some other sensors also. So for interfacing these devices, we will go with some libraries need to be attached or connected with the PIC. So that we will define with the help of include directive. And the next one is config. That is configuration. Config in the name of configuration. This directive is used for assigning some initial status of the various SFRs or specific bits. That is BOR, POR, whether it is activated, deactivated, like that, master reset, and some other peripherals functions related to that. That is crystal oscillator, which crystal is used, either internal, external, and that to the frequency also. So which type, low oscillator or high oscillator crystal is used. So these are the some additional features provided by the PIC. So according to this, as per our requirement or our selection, we need to assign the bits in this format, that is config, or another way, that is internal clock source, external clock source. We have seen that RA4 pin is used to connect an external clock. Okay, so when we are using external clock here, internal clock need to be disabled and external clock is enabled with the help of this config directive also. Okay, again timer and watchdog timer. So again these two are defined here at the start of your program. So config directive is used after ORG, and you need to define some bits like this, that is BOR is activated or not, like that. So all these peripherals activation, that is whatever initial status are there, reset or set, whatever bit setting or bit clearing, that is resetting the bits initially before writing the instructions or commands. So this directive is used, that is config. And then radix. Radix is used for defining the default number system used for a particular program. So generally by default, the number system used by an PIC microcontroller is hex values, that is hex. But if you want to change that particular system into the decimal, then you mention radix DEC for decimal. So generally it is used for defining either hexadecimal value or decimal value. So after defining here radix decimal, so no need to mention further the D. So automatically it will consider as a decimal value, as we have mentioned specifically decimal. And if it is not mentioned, or if we cannot modify these directive, that is radix, in that case default number system used by NPIC assembler is hex, that is hexadecimal. So no need to define radix hex. It is already there. But if you want to change or make it an decimal, in that case you should go with radix DEC, that is decimal. Okay. So write down this. Till you writing that, I will go for attendance. Give me attendance. Today is, I think, 6th. 9. Roll call 1.
Present, sir.
2.
Yes, sir.
3.
Yes, sir.
4.
Present, sir.
5.
Present, sir.
6.
Present, sir.
7.
Yes, sir.
8. Roll number 8. Absent. 9. Roll number 9. 10.
Present, sir.
11.
Present, sir.
12. 12. Absent. 13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16.
Present, sir.
17.
Present.
18.
Present, sir.
19.
Present, sir.
20.
Present.
21. 22.
Present, sir.
23.
Present.
24.
Present, sir.
25.
Present, sir.
26.
Present, sir.
27.
Present, sir.
28.
Present, sir.
29.
Present, sir.
30.
Present.
31. 31. 32.
Present.
33.
Present, sir.
34.
Yes, sir.
35.
Present,
35.
sir.
36.
Present, sir. Present, sir.
37. 37. Nikhil. 38. 38. Rishikesh. 39.
Present, sir.
Who is this? Unmute yourself. I'm not getting your name here. Huh? 39.
Present.
Okay. 40.
Present, sir.
41.
Present, sir.
42,
Present.
43, 43, absent. 44,
Yes, sir.
45, absent. 46, absent. 47,
Present, sir.
48, 48, 49,
Present, sir.
50,
Present, sir.
51.
Present, sir.
ओके तुम्ही चेंज करा प्रोफाइल मध्ये 52 योगेश 52
Yes, sir. Yes, sir. Yes, sir.
ओके 53 53 absent
Present. Present.
yes yes
Present.
lovely attendance 53 Rishikesh 54 54 54 55 55 56
Present, sir.
57 57 Patil Patil is not there okay 58 58 Imran absent 59 59 absent 60
Present, sir.
60 okay
Present, sir.
yes yes Pawar Avinash present 61
Present, sir.
62 Kiran na 62 absent 63
Yes, sir.
okay
Sir.
64
Yes, sir.
who is 64 64 absent Patil 57
Hello, sir.
you are present okay 65 65
Present, sir.
okay 66 67
Present, sir.
68
Present.
68
Present.
okay
Hello, sir. Hello.
have you completed
Yes,
Sir,
sir. Yes,
57
sir.
आहे.
yes 57 your attendance is marked as a present
Sir,
Patil, lovely
69 is
attendance.
also present.
Sir,
oh
तुमचं काहीतरी
sorry
प्रॉब्लेम आहे, sir.
69
काय होतं?
Yes, sir. You forgot.
yes yes 69 attendance is marked 57 is also marked both are present shall we move further
Yes, sir.
so related to the instruction set used in PIC microcontroller, that is we are talking about PIC 16F877 microcontroller. So as we have divided the various instructions in some categories like data transfer instructions, arithmetic instructions, logical, bit oriented, okay, instructions, program flow control, like that. So division or grouping of an instruction is based on their operation. So for a similar or particular structure, we will go for a specific group of instructions. So these groups are virtually made. It is not made like that. So for identifying the various instructions, we are defining with the help of some groups as per our simplicity or understanding. Okay, so in case of talking about the data transfer instructions, similar to the 8051, the meaning or function is we will transfer the content from one register to another register, or from one memory section to some register, or some register to memory section. So simply transfer, no modification in the data. Data is only transferred. So that's why it is called as data transfer group or data transfer instructions. After that, some arithmetic as well as logical operations. In that case, we will go to modify the content as a result. Okay, so that is addition of 2 plus 4. So here result is modified content. The result is not as the content in some first register and content available in the second register as it is, or any one of them. So we simply modify, that is either make addition, subtraction, either make and or XOR, like this. Okay, so in case of this group, that is ALU group or arithmetic and logical operations group, we will perform the various arithmetic and logical operations on content stored at 2 registers. 2 register मध्ये available असणारे content, किंवा content stored at one operand is register content, another operand is some specific value or immediate value. Sometimes we will go or fetch the content stored at memory location with the help of some memory locations, memory pointers, and we will perform ALU operations like that. Okay, next is related to suppose bit oriented instructions or bit operation group. In that case, we will go on this particular bit, as we have seen that if we want to use a single bit, in that case जसं की आपण set bit use करतो 8051 मध्ये P1.1, P2.3 like that. Clear bit CLR-C, आपण कॅरी क्लिअर केलंय का नाही, CLR-C. इथं काय C म्हणजे काय, तुमचा एकच बीट आहे. सेट TR0, क्लिअर TF0. आता ह्या इन्स्ट्रक्शन्स आठवा टायमर ऑपरेशन मधल्या. आता सेट किंवा क्लिअर आणि पर्टिक्युलर एकच बीट मेन्शन केले, TF0, TF1, TR0, TR1. टायमर स्टार्ट आहे, टायमर ओव्हरफ्लो स्टॉप करायचंय, क्लिअर करायचंय. हे काय आहे, तुमचे एक एक बीट आहे. त्या प्रकारच्या इन्स्ट्रक्शनला काय म्हणणार आहे आपण इथं, बीट ओरिएंटेड इन्स्ट्रक्शन्स. आता इथं सुद्धा तशाच आहेत, BTFSS या टाईपच्या इन्स्ट्रक्शन आपण पाहू. तर ज्या एकाच बीट वरती ऑपरेट होतात त्याला काय म्हणायचं, बीट ओरिएंटेड किंवा बीट ऑपरेशन इन्स्ट्रक्शन. आणि ज्याला कंप्लीट बाईट लागतो 8 बीटचा, एक बाईट असतो ना रजिस्टर म्हणजे एक बाईट, मग त्याला काय म्हणायचं, बाईट ओरिएंटेड. बाकीच्या मोस्ट ऑफ द केसेस बाईट ओरिएंटेड असतात. पर्टिक्युलर बीट वरती ऑपरेट करणारा आपण काय म्हणणार आहे, बीट ओरिएंटेड, लाईक दॅट. After that, we go for the program flow control. Program flow control instructions means what? When we start our program from org, whatever the address is there, either 00 or onwards. So after that, if we go with sequential order, that is after the execution of first, then second, then third, whatever the third instruction is there in your program, okay, written program instruction, sequential order. त्या केसमध्ये काय असेल, तुमचा प्रोग्राम फ्लो काय आहे, सिक्वेन्शियल आहे, वन आफ्टर अनदर, नेक्स्ट 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 नेक्स्ट. बट when we talk about execution of some other functions, that is subroutine functions, in that case your program counter need to be jumped to that particular memory location instead of jumping to the next. एक नी इन्क्रीमेंट, दोन इन्क्रीमेंट होऊन जो आपण एक्झिक्यूट करतो नेक्स्ट इन्स्ट्रक्शन, त्याच्याऐवजी आपल्याला काय पाहिजे, 50 नी इन्क्रीमेंट पाहिजे, डायरेक्ट तिथं जम्प करायचे, तिथले काही 8-10 मेमरी लोकेशन्स एक्झिक्यूट करायचे, मग परत रिटर्न मेन प्रोग्राम लिहायचे. त्या प्रकारच्या इन्स्ट्रक्शनला काय म्हटलंय, प्रोग्राम फ्लो कंट्रोल. फ्लो चेंज होतो ना त्याचा, त्याला काय म्हटलंय, प्रोग्राम फ्लो. म्हणजे इथं काय कॉल जम्प टाईपच्या ज्या इन्स्ट्रक्शन असतील, ओके, आपण अगोदर DJNZ, CJNE, ओके, SJMP, ए कॉल, या ज्या काही इन्स्ट्रक्शन यूज केल्या त्या सगळ्या काय आहेत, तिथं प्रोग्राम ब्रांचिंग म्हटलं होतं आपण. इथं काय म्हणले, प्रोग्राम फ्लो कंट्रोल. फ्लो कंट्रोल केलाय असा अर्थ आहे त्याचा. तिथून आपण डायरेक्ट जम्प करतोय, किंवा मिडल मधले काही नेक्स्ट स्किप करायचे, पुढे जायचं, परत रिटर्न यायचं, किंवा अपवर्ड डायरेक्शनला जायचं, परत आहे त्या पोझिशनला यायचं, त्याला म्हणायचं फ्लो कंट्रोल. आणि अदर इन्स्ट्रक्शन ज्या काय आहेत या टाईपच्या सोडून मिसलेनियस मध्ये त्या काही थोड्या बहुत इन्स्ट्रक्शन आहेत, त्या पण एक प्रकारे फ्लो कंट्रोलच आहेत. डायरेक्ट रिटर्न फ्रॉम इंटरप्ट लाईक दॅट. प्रोग्राम फ्लो मध्येच येतात पण पर्टिक्युलर स्पेसिफिक असतात. त्याचं टास्क प्रीडिफाईन आणि प्री स्ट्रक्चर्ड असतं. लक्षात येते. व्हेरियस सेट्स अवेलेबल इन द instruction set of a PIC 16F877 microcontroller. Okay. Some of the guidelines are given from the microchip. We will see these guidelines in the next lecture as I think we are having 5 minutes. Okay. Before that, I want to discuss some points before starting this. So as your result came out, is there anyone whose result is not declared yet? From your class? Hello? असं कोण आहे का की रिझल्ट लागला नाही त्यांचा?
सर बॅकला ज्यांचे होते ना त्यांचे आले नाहीत.
ओके, म्हणजे ज्यांचे फर्स्ट सेमचे बॅकलॉग होते त्यांचे आलेले नाहीयेत.
हो सर.
ओके, सर्वांचं तसंच आहे ना? ऑल क्लिअर वाले सगळ्यांचे रिझल्ट लागलेत?
हा सर बहुतेक तरी लागलेत पण ज्यांचे बॅक आहेत त्यांचे नाही आले.
हा, मग काय असणार आहे त्यात? बॅकलॉगचा थोडासा लेट लागेल, डिलेड पाहू आपण. तरी मी पण चौकशी करतो. तेच मला वाटतं एकाचा मेसेज आला होता तुमच्यातला रिझल्ट लागला त्या दिवशीच. पण मला फक्त एवढी खात्री करायची की सगळ्यांचं तसं झालंय का पर्टिक्युलर एखादा कॅन्डिडेटचा स्किप झालाय किंवा काय प्रॉब्लेम आलाय. ओके, बॅकलॉग वाल्यांचे आहेत तर ठीक आहे, मग आपण तसं चौकशी करू. कारण मोस्टली काय होतंय की बॅकलॉगचं थोडं लेट लागतंय, त्यामुळे तो लागेल असं पाहूया, बघू आणखी काय होतंय. नंतर तुम्हाला आणखी इन्फॉर्म करतोच टाइमली जे काय होईल ते. ओके. दुसरे काही इश्यू रिझल्टच्या बाबतीत? कोणाचं काही एक्झाम फॉर्म भरला नव्हता असं काही नाही ना कोण?